Okay, so this question is a superannuation question. Again, a lot of these will come in to play with a very similar process. And again, it's a super relevant thing for us to know because when we're all getting our jobs, we're all going to be paid into our superannuation fund, and that is effectively like our pension for the future, a bit of a safety net, and something that is pretty unique to Australia, to be honest. So let's read the question. Joe begins full-time work at age 25. They have an annual salary of $80,000. Their employer makes quarterly contributions to their superannuation fund, and the superannuation fund returns 3.5% per annum compounded quarterly. A few things to note here. That has given us a lot of information, and we only need a little bit to calculate part A. What we should remember is that superannuation in the textbook is 9.5%. At the moment in real life, it's a little bit higher, but we are going by what the textbook does at this point, purely for simplicity and because we don't want to get you confused. So what we're looking at here is calculating the quarterly contributions that Joey's employer pays to her super fund. So if Joey has an $80,000 salary, we need to find 9.5% of that. So I can just straight away multiply this by 9.5 over 100. I'm going to put that into the calculator. And that is telling me that Joey is going to be provided with $7,600 per year. And that is going straight into an investment which is accessible once Joey retires. We also need to be really careful here because we're looking for quarterly contributions. So your superannuation can be paid by your employer monthly, fortnightly, even quarterly. In this case, it's quarterly, so we need to say 7,600 divided by 4, which is going to give us $1,900 quarterly. So that has answered part A. Part B is using this value of $1,900 or $1,900 in order to figure out how much Joey is going to have in her account when she ends up retiring at age 65. So again, we're having to do a little bit of legwork here and pull some values from not only part A, but also in the text above. So let's have a think. Joey is starting off with $0 because we're basically saying that she has started working and she's got no money in her super fund. The PMT, $1,900. We are getting this this paid in quarterly, and the super fund is actually also returning this interest rate quarterly. So our CY is 4. Again, remember that the PY and CY don't have to be the same value. Interest rate 3.5, and future value is what we're looking for. If Joey's retiring at age 65 and she started at age 25, that means that we've got 40 years times by 4. Again, N is the years times by the PY. So we've got 160 here. So let's go into our finance on the calculator. We've got 160, we've got 3.5, we've got 0 as the PV, regular payment of 1,900. We don't know the future value. 4 and 4. Now, before we get into this, let's have a think about what we're predicting for this. You're getting almost $2,000. Well, even if we look at part A, we know that it's $7,600 per year. That's over 40 years. So we're going to assume that it's going to be a fairly decent amount of money. So let's hit FV. And as we have assumed, we're earning $658,068.98. So that is pretty reasonable. You'd be pretty happy if you can retire on that amount of money. And then again, when you retire, you don't just take out that whole amount because there are a lot of taxes on it, as we've talked about previously. If you took out all of that money, that puts you in one of the highest tax brackets possible. So you would pay almost 45% tax on a lot of your money. So part C, she is going to roll it over to a different fund, which she's actually going to withdraw $4,000 a month to live from. So she's not living an extremely lavish life. She is, if we've got $4,000 monthly, she's giving herself about $48,000 a year to live on. So that's fairly reasonable. What we're interested in is how long that is going to last her. So we are going to use the compound interest function. Once again, surprise, surprise. And let's have a look at what we need to fill in. So we're trying to find out how long this money lasts. That means we're trying to figure out N. Her new account is giving her 2.8% compounded monthly. She's also withdrawing $4,000 monthly. And if she's withdrawing it, actually, I'm just going to erase that to make it super clear. This is going to be a positive. So because she's taking that money back, that's a positive amount. Again, doing that monthly. Her FV, if she's trying to figure out how long it's going to work, how long her money is going to last for, we're going to drain that account. So that's going to be 0. And our PV, finally, because she's changed it to this other account, it's going to be minus $658,068.98. So, finance package. We're going to plug in these values. N we're going to set to 0 because we do not know what that is. Interest 2.8. PV $658,068.98. The PMT is positive 4,000 because we're whittling away at that PV. The FV is 0, the PY is 12, and the CY is 12. Our N that we have come up with is 207.8. Now, depending on what you want to do, you can round this up, but if you think about it, if she's withdrawing money, she's actually not going to be able to withdraw that last payment. So she's basically got 207 full months of payment and then 80% of that last one, but you can round that up. That is absolutely fine. The very important thing that we need to talk about though is, what does that 208 represent? That 208 is 208 months. So if we want to figure out how many years this is going to last her, we've got to divide that by 12. So 208 divided by 12, that's giving us 17 years and a third. So that is giving us 17 years, 4 months. So she's going to have that money for another 17 years and 4 months, which is fairly good. If she wanted it to last longer, obviously make the payment a bit smaller. Now, part D, again, very important to consider, especially when we're talking about investigations and things like that. Assumptions that we've made in part C. So, again, there are a few things we can consider. First of all, we're assuming that the interest rate remains at 2.8%. Now that is very, very rare. For 17 years, we would not expect interest to remain at that same rate. So that's something that we need to think about here as an assumption. For this type of thing, again, we're just doing calculations. We're not trying to do super high level economics where we've got heaps of moving parts. So we're just assuming things like that. I guess we're also assuming that no emergencies. So no emergencies where she needs more money or she needs to withdraw extra. And And generally, if you get asked for assumptions plural, you should be writing down as many as the marks are worth. So if you've got a 2-mark question saying that, you should write down at least 2 and make them individual. Don't just say interest rate doesn't go up, interest rate doesn't go down. We want 2 different things to consider there.